Hello, welcome. Today we are going to be learning separating techniques. Today we are going to be learning what? Separating techniques. We learned in chemistry that matter can be elements, compounds, or what? Elements, compounds, or what? Mixture. I will say that elements are the simplest form. Compound is when two or more elements come together and join chemically. Whereas mixture is when substances come together and join physically. So these substances that come together and join physically, known as mixture, can also be separated using physical means. Is that clear?
Yes.
And these physical means that you use in separating mixture are known as separating what? Techniques. The physical means used in separating mixtures are known as what? Separating what? Techniques. Is that clear?
Yes.
So whenever you hear separating techniques, you know that we are talking about separating mixture. Separating what?
Mixture.
Not compound, not element. But separating what? Mixture. We separate mixtures using what? Separating techniques. Is that clear?
Yes.
So separating techniques are, these are physical what? Means used to what? Separate mixtures.
Yes.
What again?
And the separating depend on the physical properties of the component.
Depending on the physical
properties of the component.
Properties of the component of the mixture. Is that clear?
Yes.
Good. So therefore, separating techniques are physical means used to separate mixtures depending on the physical properties of the component of the mixture. You understand?
Yes.
For you to separate any mixture, you need to check the physical properties of the component. You understand?
Yes.
The physical property of the component determines the kind of separating technique that you use. If you have rice mixed with sand, rice and sand, how can you separate rice from sand? What separating technique? How can you separate rice from sand? You use what we call hand picking. You understand?
Yes.
Because you can pick out the sand because of the color.
Yes.
You know the color of sand and you know the color of rice, is it not?
Yes.
You use that your tray, you put the sand, you put the rice that is contaminated with what? Sand. You do it like this, isn't it? Some will come out, you see now, you see, because of the color separation, you can easily separate the sand from the what? Rice. I will call it hand picking. You understand?
Yes.
Then if you have sand inside water, how can you separate sand from water? Can you use hand picking? No, you use sieving. Because when you place a sieve and you pour the sand and water, the water will go down from the sieve, but
yes,
whereas the sand remains. So it depends on the physical property. Sand is a metal, isn't it?
Yes.
The water that is mixed with is a non-metal. So when you have a metal and a non-metal, a metal that does not dissolve with a non-metal, how do? You use sieving. But if you have metal and metal, or when you have solid and solid, not metal, sorry, I was saying so, I meant solid. When you have solid and solid, like sand and rice, you use hand picking, is it not?
Yes.
So you need to know the components of the mixture, because that determines the kind of skill that you use. Is that clear?
Yes, sir.
So, in trying to use this, we are supposed to do some terms like solute. Solute. What are solutes? A solute is a what? Solid that can do what? Dissolve. A solid that can dissolve in a what? Solvent. A solid that can dissolve in a solvent. And solvent is always a what? Liquid. Solvent is always a what? Liquid. Example of a solute is common salt. Common salt. An example of a solvent is what?
Liquid.
Water.
Water.
You understand?
Yes.
Common salt can dissolve in water. Any solid that can dissolve, we call it solute. Is that clear?
Yes.
The one that cannot dissolve, you say that it is insoluble. Is that clear? But the one that can dissolve, we call it solute. It dissolves in a liquid known as solvent. Is that clear?
Yes.
So, when a solute dissolves in a solvent, we have what we call solution. We have what we call what?
Solution.
We have what we call what?
Solution.
So, solution is made up of what? Solute. That is what? Dissolved in a what? Solvent. In a what?
Solvent.
E.g. common salt. Common salt, huh?
Yes.
Is a what? Solute. Huh?
Yes.
And it dissolves in water. Water is a what?
Solvent.
Solvent. So two of them will form what we call what?
Solution.
Solution. So we have a salt solution. We have a salt what? Solution. Is that clear?
Yes.
When you carry rice and put in water, will it dissolve?
No, sir.
So rice, is this solute? Is rice a solute?
No.
No, it's not a solute. If you carry iron and put inside water, will it dissolve?
No.
So iron can be said to be insoluble. Can be said to be what? Insoluble. Because it does not dissolve in water. But if you bring sugar or salt and put, what will happen? It will do what? Dissolve. So whenever it dissolves, the solution, a solution is formed, isn't it?
Yes, sir.
Isn't it?
Yes, sir.
Good. So now we're going to look at the various separating techniques and see the physical properties that determine their use. We see the what? Physical properties that determine their what? Use. The physical property that determine their what? Use. So here we write the separating technique. Is that clear? Then here we have the what? Substance. Substance is what? Huh? Substances to be what? Separated. Substances to be what? Separated. Then here we'll write the what? The physical property upon which the separation depends. Is that clear?
Yes, yes.
The physical property that you use for the separation. So this table is very, very important. The knowledge of this table will help you to do a lot of things. Now then we will ask you, if we have such this and this as substance to be separated, what kind of separating technique will you use? If you have sand and water as the substance to be separated, what kind of separating technique will you use? Sieving. You understand?
Yes.
If you have sand and stone, what kind of separating technique will you use? And picking. Because of what? The color change, the color difference. Is it not?
Size.
So here you just color and the word size. So this is the separating technique. This is something that can be separated. And this is the physical property that made you to use the separating technique that you're using. Is that clear?
Yes, sir.
Is that clear?
Yes, sir.
Example of separating technique is hand picking. And what? Picking. And picking. And picking. What kind of substances do we separate with hand picking? Mixture of what? Solids. Who can give me an example of mixture of solids? Stone and sand. So when you have stone and sand, you use hand picking. So what are the physical properties of stone and sand that make you use hand picking?
Color, size.
Color and what?
Size.
Color and what?
Size.
Good. The color and the size of sandstone and rice, are they the same thing?
No.
You understand?
Yeah.
That's why you can easily use hand picking to pick it up. What another example of the separation technique?
Sieving.
Sieving. Sieving, stroke what? Filtration. Sieving, when you have something like sand and water, is it not?
Yes.
So what kind of mixture do we use sieving to separate? Mixture of what? Insoluble. Mixture of what?
Insoluble.
Insoluble what? Solid in a liquid, isn't it? So you use sieving. Because sand is not soluble in water, right?
Yes.
Sand is not soluble in water,
yes.
So you can use sieving. What are the physical properties that you consider?
Solubility.
What? Solubility, right?
Yes.
Solubility. Because they are not soluble. Solubility. They are not soluble. So that's what we use filtration for. This is filtration only. Whereas we have sieving, isn't it?
Yes.
Sieving is mixture of what? Mixture of what? Solids. What is the physical property that you utilize? Size. Understand?
Yes.
Sieving, you sieve when there is difference in size. Then you use filtration when there is what? Mixture of insoluble solid in what? Liquid. Another one is what we call evaporation and what? Crystallization. So what kind of substances do we separate?
From solution.
We need to separate solid from what? Solution. So that's a soluble solid from solution. You use evaporation. So what kind of physical property is seen here? Solubility, isn't it?
Yes.
Solubility. Solubility. Another separating technique is what we call distillation and what?
Fractional.
Distillation and fractional distillation. What substances do we separate with this?
Solid from solution.
Solvents. From what? Solution. Solvents are liquids that dissolve solids, isn't it? And dissolve other things. So when you separate them from their solution, you are using the technique known as what? Fractional distillation. So what are the physical properties that are used?
Boiling point.
Boiling what? Point. Difference in boiling point. Difference in boiling point helps you to use distillation and fractional distillation. Who can tell me the difference between distillation and fractional distillation? When the difference in their boiling points are far apart or large, you use distillation. But when the differences are very small, you understand? You use fractional what? Distillation. Fractional distillation is the technique that is used in oil companies, in petroleum industries. You understand? To separate crude oil into gasoline, fuel, petrol. You understand? DPK and all those things. You know it's one crude oil that you can separate. You have different fractions. So we call it fractional distillation. But when the boiling points are far apart, you can use simple distillation. Is that clear? Is that clear?
Yes.
You've written this down, huh?
Yes.
So let's continue. There are other techniques. There are other separation techniques. There's what we call use of Separating funnel. Use of separating what? Funnel. What are the substances that you can use separating funnel for? Mixture of what? Mixture of liquids, isn't it? What is the physical properties used here? Miscibility and what? Density. You understand? Miscibility and density. If you have a mixture of oil and water, palm oil, you understand, and water, and you mix them in a separating funnel, what will happen? The water will come down and the oil will be what? Up. Because the density of water is bigger than that of the what? Oil. So the one that has the bigger density will go down. The one that is lighter will stay up. So whenever you go and mix oil and water, put them in a separating funnel, you see that the oil will come up, the water will be down. So you can easily decant the oil out and leave the water. Is that clear? Yes, sir. Number one is that both of them are not mixable. They cannot mix together. So that's why miscibility is one of the properties. Then density will bring the water down, leaving the oil up, so that you can easily separate them. Is that clear?
Yes, sir.
Mixture of liquids like what? Oil and what? Water. You use what? Separating what? Funnel. Which other one? We have what we call decantation. We have what we call what? Decantation. Mixture of what? Mixture of what? Solid from liquid. Isn't it?
Yes.
That's what we use decantation for. So what do we consider in decantation? Density. Because the solid is always more dense than the what? Liquid. So it will float to one side. What other method? Chromatography. Chromato what? What kind of substances can be separated using chromatography?
Solvent from solution.
Solutes from what?
Solution.
Solutes from solution, like blood sample. You use chromatography for it. Solutes from solution. What is the physical property we consider? Rate of movement. Rate of what?
Movement.
And that will ask you, which separating technique uses the property of rate of movement for its separation? You say it's what? Chromatography. What other? This thing? Sublimation. What kind of substances do we separate using sublimation? Mixture of solids in which one can sublime. In which one can what? Sublime. You can use sublimation to separate mixture of solids in which one can what? Sublime. The physical property utilized here is what? Sublimation. Some substances do what we call sublimation, isn't it? That's direct changing from solid to what? Gas. In change of scale, there is normally changes from solid to liquid and liquid to what? Gas. But when a substance changes straight from solid to gas, we call it what? Sublimation. Is that clear? Is that clear?
Yes.
Then lastly is what we call what? Magnetization. It's also a separating technique. And use it to separate what? You use it to separate magnetic solid from non-magnetic solid. So we use magnetization to separate a magnetic solid from a non-magnetic what? Solid. And the physical property used here is what? Magnetic what? Property. Is that clear? So those are the separating techniques that we have. Very, very important.